All right, everyone, we'll get started again. So next up, for our last talk at BSidesBoulder 2024, we have Jacob Latonis. He'll be presenting his talk on leveling up Ghidra, learn Ghidra plugins with a Gameboy game. So please give him a warm welcome.
Hello, everybody. Can you hear me okay? Is that good? Awesome. So hello, thank you for coming to this. This was kind of an idea that just came out of nowhere, and then the talk got accepted, and I quickly had to figure out how to do it. So it's a good time, I promise. It really spawned from, I talked to a lot of my friends who are reverse engineers in the field, and not a lot of people use Ghidra, right? Like your company will either buy you IDA or IDA Pro, and then that or Binary Ninja seems to be the hot one right now. And everyone talks about how easy it is to write plugins for those. And I wanted to see if it was really that bad with Ghidra. It's not as bad as you think, as long as you're okay with dealing with Java. But as for who am I, before we jump into it, my name is Jacob Latonis. I am a senior software engineer on the threat research team at Proofpoint. So I do a lot of the development that basically makes the researchers' lives a bit easier. I write internal tooling, whether that's command line tools, full stack tools, any tech stack that kind of fulfills the niche of what they're asking for, I write. And manage and do ops for, unfortunately, as well. So that's fun. But that's what I do. I'm currently residing in Boulder. I just moved here, and it's great. I love it. So thank you for letting me join. And then what I do for fun, other than write Gameboy plugins in Ghidra, is I run, I read, I hike, and I do some open source development. So if you've used YaraX, which is the Rust rewrite of Yara, if you've used the Mach-O module, I wrote a lot of that. So if you use it and you like it, good, I'm happy. Other than that, if you've used anything in the Python ecosystem like Rough, the linter formatter, I've done some contributions there as well. Super fast. If you haven't tried it, definitely check it out. All right. So the agenda for what we're going to do today. We're going to talk about what are Ghidra plugins. We're going to dive into the Ghidra ecosystem itself, kind of how it lays out in Ghidra. We're going to talk about the possibilities of what we can do with plugins. We're going to actually show a lot of the code to write the plugin, and then we're going to do more. A lot more is when we dive into the Gameboy stuff. It's a lot of fun. And before we start, the one thing that I do want to say is that we will discuss a whole lot here today. We won't have time to dive into every topic and every piece of code. There is an open source repository on GitHub. If you go to github.com/Latonis, you'll see the GB Analyzer repo. So if you want to follow along and look at the code while we're going through it, you're more than welcome to. It should be public. And it's fully published under the Apache 2.0 license. So if you want to take it apart, change it, do whatever you'd like, you're more than welcome to. And as for the general introduction, if you're not familiar with Ghidra, it's an open source reverse engineering toolkit. It's developed by the NSA because IDA licenses cost like $1 billion each, and they didn't want to buy them for everyone. So they wrote Ghidra. It's highly extensible and customizable just due to the nature of Java and how you inherit and overwrite and all these fun things. So we can actually take a lot of parts of the UI that have already been written and kind of customize them into our own pieces of code, and it's pretty fun. And it's also free. The biggest part, as I mentioned in the start, is Ghidra is free, so the barrier of entry to get into this type of thing and writing plugins and supporting the ecosystem, it's a lot easier than having to buy a license for something and then seeing if you want to do it or not. As for getting started, we're going to dive into the architecture and ecosystem of Ghidra. This is not all-encompassing, but it does cover the points that we're interested in today. The core platform of Ghidra mainly consists of, for this talk, it's more complex than this, but for this talk, we'll simplify it. There's the flat API. So one of the things that the Ghidra developers did is they created this API that is a lot of the most commonly used pieces of Ghidra, and they took it into its own singular flat level. So you don't have to go into a bunch of different modules and grab other things. You don't have to know that this is 3 levels deep in this module, et cetera. It's all part of the flat API. So if you've written any scripting, like Ghidra scripting in Python, you've used the flat API, you just didn't know it. There's extensible components. So what that means is with Java, you basically inherit a class, and then you can modify it on top of that. And then there's the disassembler and decompiler, which if you've used Ghidra or done any RE, you're familiar with. There's export modules. We won't dive into that today, but I feel like it's pretty cool to talk about, because what you can do is you can write export modules to take the information that you're looking for or looking at in Ghidra and take it and put it somewhere else. So if you have, a workflow that is repeatable, that you constantly take information out, you can put it in somewhere else. So whether that's just JSON or any other type of file format, you can write something to do that. As for scripting, there's Python, which is backed by Jython, which allows you to tie into the Java side. And there's also, you can have scripts written in Java as well. And this is what a lot of people do for automation in Ghidra. When you look at like open source projects for Ghidra and like what people publish, you'll notice there's a lot of scripting, but there's not a lot of plugins. And I think that's just because you can fire up Python and immediately like do XYZ. But in Java, it's a little more complicated. And that's kind of the main motivation behind this talk is it's not as complex as it looks. And then finally, there's plugins. So plugins are only written in Java. Plugins are comprised of components. There's about 4 main ones, which we'll break into. And within those components, you can fire actions, or you can also talk to the flat API, which would then do a lot of the things that you can also do in plugins or in scripting. And I'm just going to break this down in a little bit simpler terms so you can easily clarify the difference between scripting and plugins in Ghidra. So scripting, again, it's written in Python, which is backed by Jython or Java. You have access to the flat API, and then it can also be ran from the command line, or you can also trigger it via an action. So if you have already things that you've developed for scripts that you call frequently, you can actually run these from actions in your plugin. So you don't have to completely reinvent what you've been doing, and you can actually leverage things that you've done in the past. And then plugins in Ghidra, solely written in Java, no Python, unfortunately. So if you like Python, you can still write things in the scripting and call them via your plugins. But when you get into the nitty-gritty of the GUI and the UI and all of that, you'll have to do it in Java, unfortunately. But it's okay. It's what it's for. It allows for more in-depth use than scripting, so you can keep state with things. A lot of scripting, you'll see, it starts at the top, it iterates through something, and then it gives you the output. With the plugins, what we can do is we can actually keep track of the state and have other things that branch off because of those changes in state, which was pretty great. And finally, the other difference is plugins can be built and distributed with the build system. They use Gradle, and we'll talk about that and we'll get into more depth with it. But instead of a script that you have to pass around and then you have to know the directory of where your scripts are, where Ghidra is looking for them, you just build the zip and then you hit install extension and Ghidra takes care of everything, which I think is a lot simpler than knowing where your working directory is that Ghidra is looking at and finding where to put the scripts and all that fun stuff. Now, finally, the exciting part, because I'm sure the Gameboy part's much more exciting than the Ghidra part. Why Gameboy? Well, first, as a piece of context, if you're not familiar with the Gameboy, the original Gameboy, was developed by Nintendo. It was originally released in 1989. It has lots and lots of games to play. And there's actually still quite a big ecosystem around games being developed in the indie scene. So even if you're not interested in reverse engineering Game Boy games, a lot of the resources that I use and talk about in this talk, you can probably turn into development resources if you would like to develop Game Boy games as well. And finally, it's still used for leisure and competitive play worldwide. Just last week, the World Competition of Tetris played on Game Boys. And we'll get into that in a little more in depth. But there's still a prominent developer and indie scene around Game Boys, which I think is pretty great. Just a couple more summary points. Small handheld video games. These are the cartridges, so the games. That's what we'll be actually taking apart today and dismantling and writing some code for the plugins. The CPU, if you're not familiar with it, it's an 8-bit CPU similar to the 8080 Sharp CPU. It's got a 4.19 millihertz CPU with 160 by 144 display. It's a little bit slower than the computers you use right today, but still pretty great. And I would be amiss if I didn't mention the resources that I leveraged to be able to do a lot of this stuff. There's an individual in the Game Boy community that goes by Gekio, and they've compiled just like this massive compendium of Game Boy resources. So they figured out all the timing and all of the, basically every part of the CPU and how it functions and interacts with the ROM and the RAM. They've documented it, which is great because Nintendo did not open source any of that, right? This is all done in a research fashion. So there's GB Research, which is the general intro to a lot of this stuff. There's Ghidra Boy, which is actually the disassembler and decompiler plugin for Ghidra that we'll leverage today. It will help us analyze some of the instructions and all of that. There's the Game Boy Pandocs, which is basically just a markdown-friendly, easy way to digest the information. And then there is the GBCTR, which is the complete technical reference. It's like a 220-page document of everything you'd ever wanted to know and probably things you didn't want to know about the Game Boy. It's very helpful. It's very useful. Now, as for the cartridge itself, each cartridge has a header, so very similar to any type of executable that you're looking at. It has a header that you need to parse to extract information out. The header contains information about the game and also the hardware that it expects to be there when it runs, so it can run successfully. We want that information. How do we get it? So I'm going to break down first the header, and then we'll talk about the use case of actually extracting that information. There's a whole lot here. I'm not going to read through each of them because we're going to go through them a little bit more in depth. So the first 4 entries, there's the entry point. Usually this is just where the code starts for the game to actually load itself. There's the Nintendo logo. So if has anyone ever inserted a game in a Game Boy and then you get that like weird line and it doesn't boot? Okay, so that's actually Nintendo's first iteration of like licensing and like making sure that individuals are licensed to develop the games. So if that like sequence of bytes is not present in the cartridge header, Nintendo actually refuses to load the rest of the game, and then you get that weird sound bite and bar through the screen saying you're not authorized to do this. So those bytes have to be present for you to have any part of the game run. And if a lot of the time when that bar is there, it's because some of the bits got lost because there's something on one of the pins or something like that. And then the next set of information is the title. It's just a short 12 character title. And then there's also the manufacturer code. And then the next 4, there's the CGB flag. So the color Game Boy came out after the original Game Boy. This flag is there to let the Game Boy know that it can use the color features. There's the new licensee code, which is the newer version of the old licensee code. And basically what that is there were so many licensees for the newer games that they had to figure out a way to add more information to the cartridge because a lot of the older ones didn't develop games anymore, but newer ones did, and they ran out of bytes. That one, the logic's a little weird, but we'll actually get into it. And then the next part of the header is the SGB flag. So the SGB flag, for those who aren't familiar with the Super Game Boy, was like a cartridge edition that you could put into the Super Nintendo, and then you could play games at, I guess, technically a higher resolution, but really it was to benefit from the extra colors the NES had that the Game Boy did not. So that flag lets it know whether or not it can be played on the Super Game Boy. And then the next one is the cartridge type. So basically, what type of hardware is present on the cartridge, like the memory bank controller, how many ROM sets are on the actual cartridge itself, that kind of stuff. And then the next set of information, basically the ROM size, so the size of the game, the RAM size, how much memory is available on the chip itself, the destination code. The destination code is interesting, and we'll get into it more in depth, but basically it's Japan market or everywhere else. That's really the 2 things that they broke down. And then there's also the old licensee code. So the old licensee code, older than the new licensee code, is basically if it's a set value, to go back and look at the new licensee code to derive that information. Otherwise, you can use the old licensee code. That's really the only amount of information in the header that is dependent on like certain values. Everything else is pretty much, you can read through and get that context pretty easily. And then finally, the last 3 sets of information is the mask ROM version number. And basically that's just what version has been published. What version of the ROM are you working with? And when I say ROM, I mean the cartridge, the game. And then the next one is the header checksum. So the header actually has its own checksum. And if that isn't verified properly, then the game won't boot. There's also the global checksum, which is a really interesting piece of information because for those who've played the N64 Pokemon Stadium or Pokemon Tower game, this checksum is only used inside the emulator of that N64 game that emulates Game Boy games. So it's there, but that's the only place that it's like documented use case. Basically, if the checksum of the entire game doesn't match, it won't play. I don't know why they did that, and it's only used there, but that's the only documented use case. So you now have a fun fact that people will love. And finally, just to kind of talk about why parsing this information out and presenting it while you're doing some sort of initial RE and triage. Can anyone tell me what Game Boy game this is from this header information? If someone like OCRs it and puts it into CyberChef, I'll be really impressed. But it is Pokemon, but what color?
Red.
Wrong. Okay. Close though, it's a color. We'll dive into which one it is later. We'll parse it out. So this brings us to our first use case that is probably pretty relevant depending on what type of binary you're looking at. we need to write a parser. And if you've ever written a parser, you know the position of how the header is defined, and you get those bytes and you turn it into human readable information. Because as we saw on the last slide, it's not exactly human readable. Cool. And the next thing that is relevant for when we actually go to write the plugin, there's I/O ranges. So when instructions want to write to the I/O, the screen, the sounds, the read from the joypad input, things like that, they'll be reading from these addresses. So if we wanted to actually analyze what functions are touching what parts of hardware, we need to keep in mind these things. And that's really all I'm going to go into for now. We're going to dive into how we do that later. But just be present that there are static addresses that we can talk to the hardware, and it's relevant for when we need pieces of context out of the code. Now we're actually going to talk into the fun part. We're going to dive into how the plugin is actually structured, how it's written. We're going to look at some Java code. So if someone has like traumatic experiences with Java, I apologize. Most of the code coming up is Java. So writing a plugin, what do we actually need to write the plugin? It's not that much, I promise. You need a whole lot of Java. So unlike scripting, which I talked about before, the plugins need to be written in Java. So if you have an aversion to Java, I'm sorry. If you love Java, I'd love to know why that is and maybe tell me afterward. And then the plugins use the Gradle build system. So Gradle is what's used for Ghidra itself, and it's also what's used for the plugins. And you don't have to know a whole lot about how the build system works. You just have to know that Ghidra ships a template for you to build the plugins with, which is really great because I didn't want to figure out the Gradle build system. Jenkins is enough for me. And then finally, if you've never looked at Java docs before, I'm happy for you because Java docs are the really it looks like it's built in like 1998, right? It's like that Oracle vibe of it's a lot of information. There's not a lot of pretty things or fun things to look at. It's just straight wall of text. So if you're diving into certain parts of Ghidra and what you want to extend, you'll have to get a little bit comfortable with looking at that documentation. More often than not, there's probably a GitHub issue or anything like that talks about it, so you don't have to look at that. But there are some use cases where you have to look at the docs, and it will happen, but getting comfortable with reading those type of docs will benefit you because it's much more difficult to read those than any other documentation I've ever encountered. Maybe not than Apple, but almost everything. So writing the actual plugin. There's actually a lot of things that we can benefit from so we don't have to start from scratch. So Ghidra provides quite a few examples for us. They provide scripting examples. They provide plugin examples. They provide export examples, a lot of cool things like that. And they're all located in wherever so if you haven't downloaded Ghidra before, it's basically just an archive, and then you extract it and you run it from that archive. So a lot of people put in opt and then keep it there. Wherever that you have extracted that to, you have extensions and then Ghidra, and then inside of there is a lot of great things that you can leverage. So you don't have to start from ground zero. And then finally, what do we need to actually write the plugin? If you've ever written Java, you've probably used IntelliJ, and it's a lot nicer than Ghidra. I'm sorry to inform you that you have to use Eclipse if you want all the nice things. It's only a lot more painful than IntelliJ. Is an extension that the Ghidra developers have written to help you develop. And basically what it allows for is you can generate skeleton files. So you don't have to start from the beginning. You can generate skeleton files to at least get your plugin present. Maybe no functionality, but it be there. And it allows us to start really quickly and start iterating. And then finally, Ghidra Dev also allows you to debug in real time. So you can hit the run button in Eclipse, and then it will spin up a debug instance of Ghidra, and you'll be able to see the errors or whatever you're printing to the console or anything like that. So if you want all of those niceties, you have to use Eclipse. Nothing is stopping you from setting it up and then running it via IntelliJ, but you won't have the debugging. But maybe that's something that one of you want to contribute back to the open source ecosystem. That'd be cool, right? But if not, I understand because I didn't want to do it either. And then finally, Ghidra Dev is also located and shipped with Ghidra. So it's in the extensions, Eclipse, and then Ghidra Dev directory. And essentially the bottom right, I know it's not too visible, but really that's just the screen you see when you install extensions into Eclipse. And then you just drag and drop it. And then it brings you a new window, and it's basically what do you want to create? So when you go to actually create it, you can select what type of plugin you'd like the template for. In our case, we only did plugin, but there are plenty more that you can do. Like if you wanted to, for some reason, have some sort of new analyzer or new loader or anything like that, you can get started really quickly. Now, the one thing that I found really difficult, I don't know about everybody else, I'm not good at UI and UX. Like the website that Heidi showed is what my personal blog looks like because I'm not good at UI and UX. So basically, it ships with tools that you can actually leverage to do the UI stuff. So it's a plugin called Window Builder, which comes with Java Swing, which is what Ghidra leverages for their UI. So it's actually like what you see is what you get. So you can drag and drop things, and it actually generates the code for you in the file that you opened with it. So it's built into Eclipse. It's just a white box because I'm going to show you my wonderful piece of UI that I first started with. Super good, super great, super clear, shows a lot of information. This is the header. If you can't tell, you probably can't. This is the header and all of the relevant fields. It gets better than this, I promise. But this is just to show where we started. And then I found that plugin existed, and we went from there and got a lot better. And if you get frustrated with it, others have too. There's more than one issue on GitHub where Ghidra has said, we're going to stay with Java and Swing. You're welcome to rewrite the entire thing, but we're not switching. You can actually see right here, immediately after creating it, well, the user's also deleted at this point, so maybe that has something to do with the NSA. I don't know. But they closed it and locked it and limited it immediately. So they're sticking with Java and Swing. So if you want to get into the Ghidra ecosystem, it's Java and it's Swing. Now, finally, we're going to get into the actual code of the plugin. So the plugin component is where you define the plugin itself to Ghidra. So it's the name, the information, what version you're expecting it to run. Do you have a help menu? Simple things like that. And basically, this is it. This is the constructor. So when you go to initialize it, Ghidra will see that this is present. It'll see that it uses the plugin tool as a parameter, and then it sees that you call the super, and then it initializes it for you. And then basically, when you go to run, you'll see your plugin present. Now, it doesn't do anything at this moment in time, but you have a plugin, and it's running. And a lot of this skeleton code was generated. The only thing that I changed, obviously, was I named it. So it says Gameboy plugin instead of just plugin. And then this is where you initialize things like the provider. The provider is terminology basically meaning what the user sees. So it provides the graphics to the user is how I thought about it. It does a lot more, but that's the simplest way to think about it. And then the other thing that you can do in the plugin is basically when certain things happen in Ghidra, you can overwrite what behavior your plugin does. So for instance, I initially found out that if there is no program loaded in Ghidra and you try to read any of the addresses, it crashes because it's a null pointer, right? Thanks, Java. Turns out you can actually control when your plugin loads. So what I did was I overwrote the program activated function call. And then basically I said, anytime the program is activated is when I want my plugin to actually initialize. So if you don't have a program loaded, it won't crash anymore. And there's a lot of things like that. Like you can do when an analyzer starts, when the program is activated, when you open up the database of the actual program itself. There's a bunch of different calls that you can have. And then next, we'll get into the provider component. So the provider, again, is kind of like the UI. This is where you define a lot of the layout, the GUI. You also initialize your actions and your callbacks. So actions are just little, like, you can press a button, or when the state changes or something like that, it allows you to have things that fire based off of those callbacks. And then it will do the things that you tell it to do. And this is where we get our first taste of Swing and Java UI and all that wonderfulness that it is. You can see that we initialize the panel. The plugin gets brought in. And then we also initialize the help a little bit further. But I have a couple of, so like the build panel line and the create actions lines, those are mine. So basically I'm saying build the GUI to show it to the user and then create the actions. And then other than that, you can set like the window title and all that fun stuff. I always thought Gameboy was one word. Turns out it's two. I didn't know that. Kind of like Spider-Man with a hyphen. It's there. But these are two examples of the actions. We'll dive into it a little bit deeper later. But essentially, I have an action that when the program loads, if it's a Game Boy game, we want to parse the header. And And then we also have one, if I click this button, I would like to generate the checksum. Because if it's a checksum, it should be verifiable. Maybe not secure, but verifiable. And we get into that. But those are two. You can see that there's some helper functions in there, and we'll also dive into that. But that's really all actions are. It's you define a callback, you put code into it, and then you can go from there. And just a reminder, if you're trying to read through all the code and it's a little too fast, the repository is on my GitHub, and you're more than welcome to dive into it. So for docking actions, the docking actions are over there on the right side. The icons, Ghidra is a little blurry when they render the icons. I apologize for that. But basically, those three are things that I defined for the plugin to do. The first one is, I'm pretty sure it's to parse the header. The second is to add comments. And then the third is to, well, we get into it. We'll do it a little bit later. But basically, docking actions are the third piece of what you define to actually do some fun things in Ghidra. It's when a trigger occurs. So a button click, a state change, things like that. They're small functions that can call other things or behavior. I think the only main important part to talk about docking actions is that you don't need to do all of that behavior in that piece of code because it is just it's like a Lambda function in Java. So you don't have to have all of your behavior and analysis in there. You can have it somewhere else and just call it and get the output because then it stays a little bit cleaner and you can organize it a little bit better. And here's another one of the actions. This is the checksum one to break it down a little bit better. But basically, we pass in the title of what we want when we highlight over it. These are print lines just so you can see it in the console, but it'll also display it via the GUI. You can see that via the checksum dialog. And I will show you these examples. I just want to show you what the code looks like first. And then you add it to the program, and that's really about it. And then the final one, which is not a part of Ghidra or the skeleton code that they give you, but I found it a lot more helpful to define like a helper class or a helper component. So I have a class where all of my functions and analysis and everything is defined inside of that. So I'm not putting all of my parsing and all of that inside the plugin or the provider. I just want to be able to call a small function and it handle the rest of it for me. So it lets you abstract things. You keep things simple. Then when you have a bug or something doesn't parse right, you know that via the stack trace, it's in whatever portion of your helper instead of provider line 9633 or something. You can keep state, you can perform calculations. There's a lot that you can do. Anything that you can do in Java, you can do inside of it. And then you leverage it to make things simpler and repeatable. And this is what the initialization, well, some of the initialization of my helper class actually looks like. So I take in the plugin itself. I take in that flat API that we talked about earlier. I have a whole bunch of hash maps. I don't know if this was the most efficient way. Someone's probably going to bully me after this talk and say this wasn't efficient. That's OK. Please do. I don't know Java well. But basically, I set up, there's a lot of context that is in byte form that we want to translate to human readable context. So essentially, I took all of those byte entries and created hash maps to have the human readable side. So I input the bytes, and then I get the human readable context that we can then use elsewhere. And then I have the checksum field because it's just stored as an integer. But basically, I initialize my helper. I build out the maps. I build out the header, which is parsing it and storing it. And then I build out the licensees because there's I'm going to show you as an example, but there are so many licensees for the Game Boy games. And we'll get into a pretty gnarly case of the licenses in a minute. But when I say make things simpler, I really do mean it. So what you can do in your helper functions so you don't have to have all this bloat everywhere else is, for example, if I want to get the name of the program in Ghidra, so that API, that's that flat API. And we can do get current program, get domain file, get name, right? And writing helper.get program name is a lot easier than writing all of that. Similar for path, so where it is on your system, SHA-256, MD5, all of that fun stuff. Set code comments is one that we'll dive into later. And then the get licensee, so this is where we talked about, this is the one part of the header where logic is actually required to parse it. It's not just a set of bytes. So at first, we get the old licensee code. And then if it's the hex value of 33, we then know that we need to not use the old licensee code, and we need to go get the new licensee code. Great naming conventions. And that's how we do that, right? So we compare the address value. The flat API has an API.getByte, and you just pass it a pointer to an address. But for whatever reason, you can't just pass in an integer. You have to convert it to an address first. I probably could have overridden the getByte to accept an integer. But Ghidra provides the API.toAddress, and you just pass in an integer, and it converts it to the address that it's expecting, which is really easy. And yeah, you can see I have great error handling here. It'll just return nothing if it errors. Yeah, that's how you get the license code. And then you'll notice that we use our old licensee or new licensee map, and we turn it into human readable text. So this is what we showed a little bit earlier. I figured I would show the whole hex dump now. So it's not Pokemon Red, it's Pokemon Yellow. But you can kind of see there are some things that we can parse out just by looking at the hex. But there are some things that, like, for instance, after the title, you don't know that licensee code 01. You have no idea what that is, right? If someone does, I'd be impressed. OK. You'll be shocked that licensee number 1 is Nintendo, by the way. But basically, we now parse it. So in my helper library, what I'm doing is I'm getting the header. So I start with my pointer at 100. In one of my maps, I had it defined of the addresses for each part of the header, and then it just iterates until it hits that, and then it adds it to my structure that has the header. And basically, it iterates through all of those. It gets those bytes. It increments the pointer, and then it returns all of that in the end, and it also sets it for the class state, so you can use it in other parts of your helper. And since we've done this at the start, we only have to do it once. So if any other point in our plugin we want to manipulate or look at any of the header, it's now saved in our helper component. Whereas if you wrote this in one of the actions, you wouldn't have this be accessible anywhere else in your plugin. You'd have to copy and paste the code again, which is painful. And you also have to remember where it is and where to go get it from. So just to hammer the point home, here's what the header looks like before we turn it into human readable context and all of that fun stuff. So you can see the Nintendo logo. That's the first string of licensing that we talked about earlier. It's not a straight line. It's encoded in like quadrants. We'll leave that there. It's encoded in quadrants. So essentially, it renders it in a cool way. I don't actually know the math because the video game math on pixels of screens that small is difficult for me. But you can see we have a whole lot of stuff here. And I'm about to show you my super efficient way of how I keep track of all of this. So if there's another way to initialize maps, please tell me, because I don't want to keep doing this. But essentially, I build out my licensee maps. You can see that if it's 00, there's not one, Nintendo, Capcom, et cetera. There's one specific one that we'll talk about when we get to a specific game and all that fun stuff. And then you can also see, when we talked about the cartridge type a little bit earlier, it's basically what the game is expecting to be able to actually run. So if the console that you plug it into doesn't provide these things, it won't run. But you can see there's a lot of variants. You probably didn't know there's that many variants of a Game Boy. And then finally, this is the new licensees. So there's more. Nintendo's still the first. There's a whole lot. But really, it's nice context to have when you're doing things like this. And for an actual example, a real use case, when you're pulling apart a header for a binary like a Mach-O, instead of having that like the integer of whatever byte you're reading, you would then map that to like whatever the constant name is or something. So you have a human readable, comparison. And then with verifying the header information, we talked about how there's a checksum earlier. So now we can actually calculate the header checksum. The checksum's pretty easy. You just start at 134 and you go until 14C, and then you just subtract it from itself, and then you get the bottom set. And that's really about all you do. Now, the one thing is that you'll probably notice for anyone who is familiar with checksums and stuff, this isn't like actually that secure. If I change the header, I could just recalculate it and then overwrite the header byte. That's true. You could do that. But it's mainly a way to ensure that whatever's there is that it's ready to run on the console. So if someone modified something on the first set of bytes and then they forgot to modify the checksum at the end, the console won't run it. But see, I got better at UI stuff, I promise. It doesn't all look like the first example I showed. So basically, the given checksum is what's in the header. The calculated checksum is what you calculate with that function. And then it's green or red with valid or invalid, depending on what it calculates. This was when I figured out that the window builder was a thing, and it made it a whole lot easier and a lot more fun. So with that, we know that this information is good. And if the information is good, that means we can probably present the other information to the user. So we've parsed out, now the first 4, the file information, that's from Ghidra itself. So we didn't get that from anywhere. Please don't judge the ROM name. I would never download ROMs illegally. Please only dump them from your cartridges. Just clarifying. The title is Pokemon Red. The licensee is Nintendo Research and Development 1. And that 1 is there for a reason. They did have different research and development labs. There's a book a little later on that we'll talk about in the talk. You can actually read the differences in culture and vibes between the 2 research and development facilities. And then the destination code, as we talked about earlier, was not Japan. It was overseas only. Does anyone know why Pokemon would be overseas only? Does anyone know what Pokemon is called in Japan? Yes. So they wouldn't want to sell Pokemon in Japan. Instead, it's Pocket Monsters. So that's why this one is distributed as overseas only. The ROM version is the initial version, 0. The ROM size is 1 megabyte. And then the cartridge type, it has a memory bank controller, RAM, and a battery. And the battery is to save state when you turn the game off, right? So if anyone's ever, turned on their Pokemon Blue from way back when and your save was not there anymore and it didn't save when you turned it off, that's because the battery's dead. If you pull apart the cartridge, you can replace it pretty easily. Now, finally, who knows Tetris? Who's played Tetris? Okay, almost everybody. So if you're not familiar with Tetris, instead of showing you the game, I'm going to tell you about 2 pieces of media instead. The Tetris Effect is a really good book that talks about a lot of the licensing woes of Tetris, that when it was originated in Russia and brought over and sold to a whole bunch of different companies illegally without the knowledge of the developer, you'll actually see that some versions of Tetris have a different licensee for the Game Boy than other versions, and that is dependent on who had the rights to publish the game. And then finally, I think it's on Apple TV, right? There's a Tetris movie about the exact thing that I just talked about in the book, but it's a little bit more dramatized. And if you're not familiar with how many versions of Tetris there are, these are all separate versions of Tetris on Game Boy, right? So imagine that this is a real use case for a plugin like this. Imagine you are a collector of retro games. You probably want to know what version you're buying, right? So, instead of like stock X for shoes, you could have stock X for Game Boy cartridges, and you could analyze all the headers and see if they're the right ones. So if you are not a Game Boy game collector, the Tetris version on the left of that right picture is called the Minuet version, and that's like the super rare version of Tetris. It has an extra soundtrack. That's the only thing. That's the only difference. That's it. But everyone really cares about it because it's different. And it also has slightly different cover art. But if I were a nefarious person, what I could do is I could buy a whole bunch of the ones on the right, print out the label of the one on the left, and if I didn't know about this header information, I could probably just tell you it's the Minuet version, right? Well, say that happens, I get the game, and I dump the ROM, and I'm like, oh, this isn't the Minuet version. That header information will actually reveal to you, assuming they haven't modified it, that it's a different version of the game. Because most people who are doing scams like that probably aren't going to know about the header information. So it's a cool use case that's actually applicable to the real world. And then finally, these look like the same version of Tetris. The colors are a little more faded, but the header information is different. So when we go to parse it out, you'll see that the ROM size is the same, but the versions are different. And things like this, for example, for the competitive Tetris scene, you probably want to know what version all of the competitive players are playing on, because if version 0 runs slightly faster than version 1, someone has a competitive advantage. It's probably relevant to talk about. You're probably not analyzing binaries that aren't Game Boy ROMs for anything else like this, but it's a cool use case nonetheless. Now, the next use case is I/O. So we talked about all that I/O addressing a little bit way back when. And what we can do is you can either remember all of those addresses in your head and jot it down. You can add comments manually in Ghidra when you analyze. But if I were to show you this, you can see that it's going offset to an address that's defined, but you don't really know what it's writing to or reading from, right? So we can actually use that contextual information, and we can write something that finds addresses that use that offset, or the offset goes to that location, and we can add comments on the side there to say what it's reading to or writing to or reading from, which I think is pretty great. So if you have defined registers that you want to keep track of, or even just specific addresses in the code that you're looking at, you can do it like this. Now, here's another really efficient, I'm sure, hash map of human readable context. But this is some of the stuff from that Pandoc site that I mentioned earlier. It's provided to you in a nice way, and I just wrote a regex little thing to address to human readable. So you could effectively write something that iterates through each instruction, looks at if it's a reference to something else. If it is, you can then insert those strings on those pieces of code. That way someone knows what they're looking at. Makes it a little bit easier, right? You don't have to remember it. A little more straightforward. And how to do that, this is probably the grossest piece of Java so far. But essentially, the flat API provides you with a mechanism to get an iterator of all of the instructions. And then from there, while the iterator still has something next to look at, you can then get the instruction from the iterator You then parse, you get the address, you get the physical address because everything is on the ROM, so it's all physical. And then you get the offset. If the destination is actually something that we cared about tracking, so we initialize that big hash map of addresses that we cared about, we get it, and then we can use this code unit. So Ghidra breaks things down into code units, and it's like database under the hood. And you get that code unit. Usually it's just a line of code. Sometimes it's a function. And you can add comments. So you can either add it to the start of the line, the end of the line, right in the middle if you want to make your life a little bit more difficult in reading things. But you can put it somewhere, and then you can insert whatever piece of relevant context. That way, when you go back through to look at the actual code, you have better information. And then finally, the ones down at the bottom, I just thought it was relevant to when I scroll through the ROM and I see those addresses, it would be a nice reminder to have those listed as well. So it's not an instruction that's talking to it, it's that actual address. And then you have to end the transaction to commit it, similar to like, if you're writing like, I think it's SQLite under the hood, so you have to commit the SQLite transaction. Don't quote me on that. I'm not sure if that's actually true. But yeah, so the finished, in quotes, product, because we could always improve on it. When you would go to the window, you would see our Gameboy analysis plugin. This is the initial screen that we have here. So we have all of our parsed information. And then we also have our docking actions, right? So we have the code commenting, the calculate the checksum, and then we also have the source code add comments to the code. And I thought it was relevant. We could add some of the favorite games and just kind of look at the header information because it's fun. And if I offend anybody by not putting your favorite game, I'm sorry. I apologize. But Pokemon was, my go-to. Kirby's Dream Land, it was mentioned in the tweet that talked about this talk, so I felt relevant to put it in there. And then I was a big fan of like the Spider-Man and like Batman animated series games, so I felt it relevant to mention that one. It's just a side scroller where you beat things up, but yeah. If you are interested in the source code, it's available on my GitHub, so github.com/Latonis/GBAnalyzer. I do have stickers of that logo without the GB Analyzer, so if you're interested in a little Game Boy with the Ghidra logo in it, please approach me. I have like 30 or 40 of them to give out. I got really into it. I designed the logo by hand. It was great. You can tell that that's very representative of my UI work as well. So. And then finally, I did include some utilities in the GitHub repository. So if this turns into something that you'd actually like to distribute out into your org, not my Gameboy plugin, maybe, I don't know. But like if you turn it into something where you find it relevant to distribute to the other REs in your org or anything like that, or you want to define a plugin to contribute to the open source ecosystem, I have a GitHub workflow that basically sets up Java and then sets up Gradle, and then it will install Ghidra because you have to have Ghidra to build it because it uses that template. And then it will actually publish it to your artifacts, like the artifacts part of your repository, and then you can create a release from there and actually have it like on the releases site. So if you would like any of that, the hardest part was setting up Gradle. I don't know why, but it just didn't work well. But this works. So if you're interested in using this and defining like an actual plugin and you want to distribute it, please feel free to take this and do whatever you need to do with it. And then finally, there are a couple of plugins that I thought were relevant to mention that I've seen that I thought were pretty cool. Not written by me. There's VT grep Ghidra, which is a heck of a name. It basically integrates functionality from VirusTotal, so you can write like retro hunts or live hunts if you're familiar. So you can actually take parts of the binary that you're looking at and create those rules via API, and it will do it all from Ghidra. I'm sure it's pretty cool. And then there's also Ghidra Lookup. Ghidra Lookup is a plugin that helps users look up documentation of Win API functions. So it will actually display it to you in the GUI of when you see those Win API functions in the code itself. I'm not affiliated with either of these. I just thought they were cool and thought it was relevant to mention that there's probably a lot of plugins for Ghidra that you may not be aware of, and it's a cool ecosystem to check out. And then finally, if you're trying to do something with a plugin like this and you get stuck, there's not a lot, but there are some use cases and examples on the internet that you can look at. So if you're not familiar with GitHub's new search that came out like last year, 2 years ago, somewhere in there, search has gotten a lot better. So like it's a whole lot better. It doesn't just show you like 3 repositories and 2 lines of code anymore. It'll search a whole lot of things very quickly. So you can do import Ghidra and then do the logical and extends program plugin. You can also filter by file type of Java if you'd like. But it'll give you a lot of examples that you can pull from, and it's open source, so feel free to rip the examples and try what you'd like. And then I know you're not supposed to put QR codes anymore, please don't bully me. This is to the repo, that's all it is. If you don't feel comfortable scanning the QR code, it's just github.com/Latonis/GBAnalyzer. And I think, yeah, that's last 5 minutes for questions if anybody has them.
I'll start out.
Canva is actually incredibly useful. I have a couple of friends or coworkers' friends, they're also friends, that told me that Canva is really great for stuff like this. It is, yeah, they're right. Yeah, super great. But when you export to PowerPoint, the animations don't work and your slide-ins don't work. So if the internet would have went out, I would have had to really hustle.
So this was very surprisingly relevant to the work that I do, because I'm a docent at the Media Archaeology Lab, which is here at CU Boulder.
Nice.
It's the largest collection of retro computing devices in North America. So I'm inviting you to come down and play the Gameboy games that we have.
Absolutely.
And I love this. So I just want to say thank you for doing it, and thank you for the graphic design.
Awesome. Thank you very much. That's awesome. Very cool. No one's bullied me for the hash maps or anything, so this is good. This is good.
What, if there aren't any, I'll ask one. So what was the most maybe surprisingly pleasant part of writing a Ghidra plugin?
Sure. So I wasn't relevant, like informed with the flat API. I was used to diving into each function, and when I first got into the Ghidra development, I was like, oh, this is gonna suck. Like, this is awful. No, the flat API actually makes it a whole lot easier. And due to the flat API, a lot of the scripting examples that you'll see that people have published, like a lot of like EDR firms or detection firms, consulting firms, will publish like scripts to analyze binaries that they're writing a report about. And you can actually use those because in Python, it's labeled the exact same way as in Java. So if it's, library.module.function, it's the same way in Java. And that was the most surprising part because I was really going into it expecting to like hate doing all of this.
It seems only fair to also ask, what was the most unpleasant part?
The GUI, the UI stuff. Java Swing, the only time I've ever touched Swing was my first semester of undergrad a long time ago. And it brought back a lot of the trauma from that. And like writing it on paper, I don't know if anyone else had to take Java exams on paper, but it brought back that. And I did not enjoy that at all. But other than that, it was great.
Cool, all right.
Thanks.
More questions? Speaker again, thank you.